Continuing lesson 13.4 about graphing the sine function. In this lesson, we will graph a couple of sine functions using the 5 important points. Okay, our first example is y equals 1/2 sine 2 theta. So we know that the amplitude is 1/2. We know that the b value is 2. And so the period to the function will be 2 pi divided by b, which is 2. So the period is pi. So if we're going to graph this, we start at the origin. And from here, since a is positive, we will go up to the amplitude. So if this is 1, we'll be going up to 1/2. So we're going to go up to 1/2. We'll come back to equilibrium, the x-axis of the equilibrium. From there, we will go down to 1/2. And finally, we'll come back to equilibrium. So our graph will go like this. Okay, then we have to label the x-axis. So we know that the distance to the end of the first cycle is equal to the period. So this is pi. So halfway through the cycle here would be 1/2 pi. And the distance from the beginning to half a cycle would be 1/2 of 1/2, which is 1/4, pi fourths. And finally, this point in between 1/2 and a whole would be 3/4. So those are our 5 important points, the starting point here, and then each of the x values coming across. Okay, then we'll do our second example. Our second example is here on the bottom of the page. So our equation is y equals 3 sine pi halves theta. So that means a is 3, b is pi halves. So the period to this function is 2 pi divided by pi halves. So that means we're dividing fractions, which means multiplying by the reciprocal. Pi's will cancel and we'll get 4. So the period to this function is 4. So for graphing it, our 5 important points, I'll put those on first this time. 5 important points, we'll start at the origin, and then once you get to the 5th point, this would be the end of the first cycle, and that's equal to the period. So if this is 4, that means we're counting by ones. This is 1, 2, and 3. The amplitude is 3, so we go 3 in both directions. And then our sine curve, starting at the origin, will go up to the amplitude at the first point, back to equilibrium by the second point, to the negative amplitude by the third point, and back to equilibrium for the 4th point, like so.